So I'm still simplifying. This and that is going to give me x to the -1 minus, we know that half minus 2 is -3/2. Okay, so this is our new y. Now let's find the y dx. I'm just going to use the rules. So this and that will give us -x. We subtract a 1, we shall have a -2. This negative and the negative, we shall have a positive. 3 times 3/2, that's going to be 9/2. With x, if we subtract a 1, we get -5/2. That's what I'm getting at. So since the question was not specific of positive exponents in most cases, just stop, don't stress. Then we have y/3x is equal to 1 plus x squared. Just jot it down here. I'm saying y/3x is equal to x plus 1 squared, or 1 plus x squared. It's the same thing, guys. Okay. So first make y the subject, so that it is 3x into x plus 1 squared. Open this up. That's going to be x squared plus 2x plus 1. By square brackets, we are foiling. Okay, x and x is squared. Then open this, simplify it. That's going to be 3x cubed plus 6x squared plus 3x. And then dy dx, 3 and 3 is a 9x. We reduce that to a 2. And then 2 and 6, that is 12x. Reduce that. And then that will reduce to a 3. So that becomes our final answer. 9x squared plus 4x plus 3. Now, guys, the order does not really matter. Okay, whether the 3 comes first, or the 12 comes first, or it doesn't matter. Unless if the question told you that you must give it in a particular format. 6.3. Okay, there is a function f that is given as x squared plus b over x. And this function has a minimum value of 12 if x is 2. Find the values of a and b. So whenever we talk about minimum or maximum under calculus, what must come into our mind should be the derivative. It's minimum or maximum. So one thing we also know is that at this point, the coordinates of x are 2, the coordinates of y are 12. Okay, that is number 2. Then going back to the derivative, we know that at the minimum or maximum, the derivative will always be equal to 0 if we replace the x as a 2. Okay, so what do we do first? I'm going to find the first derivative, just like I said. If not, I feel like that is what must be done. Ax squared plus b x squared plus b over x. That is my y or my h of x. Okay, then I'll change that so that I have x squared plus bx to the -1. So my dy dx being equated to 0 because I know that the derivative represents the turning point. And at turning point, the gradient is always 0. So that's going to be 2ax minus bx to the -2 must be equated to 0. But we know that at that point, x is a 2. I'll replace x with a 2. So that will be 4a minus, that's b minus 4 is equal to 0. Okay, So I can choose to make B the subject or make A the subject so that my 4A is the same as B over 4. Multiply both sides by 4 so that B is 16A. That is equation number 1. Then at a point where X is a 2, Y must be a 12. Okay, remember it's part of the graph, 2 and 12. So I'm going to substitute 2 and 12 into this equation. Where there is Y, I replace with a 2. That's going to be A into 2 squared plus B over 2. Okay, so 12 is equal to 4A plus B over 2. But what did we say B was? B was 16A. So that is 12 is equal to 4A plus 16A over 2. Okay, so 12 is equal to 4A plus 8A. 12 is equal to 12A. Divide both sides by 12, which means that my A is a 1. Does that make sense? Does that make sense? A is a 1. What was the question asking for? To find the values of A and B. Okay. Then I just need to replace this A into this equation 1, because this was my equation number 2. This was equation number 2. Okay, so which means B is going to be 16 times 1, which is a 16. So guys, that's what I get. A is 1 and then B is 16. All right, we move, guys. We move. That was 6.3. 6.4. No, we don't have 6.4. It's just question 7. Okay. It's just question mark 7. Okay, question 7. Still calculus. Are telling us that the graph of a cubic function f has